A development team is building an application that uses AWS Lambda. They need to implement a canary deployment strategy for updates, which requires an automated rollback mechanism if any failures occur during the deployment. The goal is to identify 3 essential components or steps to design the CI/CD pipeline and the necessary infrastructure as code to support this requirement.
Let us look at the options. Option A, develop an AWS CloudFormation template that defines each Lambda function using the AWS Lambda function resource, including version resources and an alias configured to the latest code version. Option B, develop an AWS Serverless Application Model, or SAM template, using the serverless function resource type, incorporating the auto-publish alias and deployment preference properties configured for a specific canary deployment. Option C, establish an AWS code commit repository and an AWS code pipeline. Integrate the repository as the pipeline source and utilize AWS code build to execute the deployment of the SAM template using a build spec file. Option D, configure an AWS code commit repository and code pipeline. Define an AWS code deploy deployment group with a canary configuration and include an application specification file to trigger the CloudFormation deployment. Option E, set up Amazon CloudWatch composite alarms covering the Lambda functions, specifying evaluation periods and dimensions to initiate a rollback if errors are detected.
In my view, the correct answers are options B, C, and E. Option B is the most efficient approach because the AWS Serverless Application Model, or SAM, has a built-in deployment preference property that natively supports canary configurations. This feature handles the complex task of traffic shifting and automating the rollback process without requiring extensive manual setup. Option C is correct because it identifies the necessary CI/CD foundation. You need a code commit repository and a code pipeline to orchestrate the movement of your code, while code build is the standard tool to package and deploy your SAM templates effectively within this workflow. Option E is also a correct component because a canary deployment needs a health check mechanism. By setting up Amazon CloudWatch composite alarms, you provide the monitoring required to detect issues. When those alarms trigger, the automated rollback process can initiate, which is vital for maintaining system stability. Regarding the other options, I believe option A is incorrect because manually configuring aliases and versions is overly complex compared to the abstraction provided by SAM. Option D is incorrect because the application specification file is not used to deploy a CloudFormation template in this specific manner, and SAM already handles the underlying deployment logic automatically.